Hello everyone, I am Dr. Krishna Sarker, Department of Electrical Engineering. Here in this session, I will be going to discuss about Laplace transform of several useful functions. Lecture series on control systems, mathematics, network theory, power systems. Lecture number 6. So our new topics, Laplace transform of several useful functions. What is Laplace transform? This is the formal definitions. The Laplace transform of a time domain function f of t, which is defined for all real numbers t greater than equals to 0. It is assumed that the value of the function is 0 for t less than 0, and also which is represented by f of s. So Laplace transform, this is the time domain function which is denote f of t, and the number which is defined for all real number t greater than equals to 0. If this is our t tends to infinity, this direction real axis, and if this is t, so satisfied t0 to t tends to infinity. But it is assumed that the value of the function is 0 for t less than 0. This is the minus infinity, t equals to minus infinity. So in this period or in this region, the value of the function is 0. The value of the function is 0. And Laplace transform of f of t, Laplace transform of f of t represented by f of s, f of s. So this is our time domain function. This is the frequency domain function. So Laplace transform time domain to convert time domain to frequency domain. It is an unilateral transform, and the Laplace transform of a time domain function f of t is given as, this is the f of s, Laplace transform of f of t equals to 0 to infinity f of t e to the power minus st dt. So Laplace transform of f of t, this is the function f of t equals to f of s, and which is equals to 0 to infinity. This is 0 to infinity, that's why unilateral transform, because this is satisfied only positive direction 0 to infinity and does not satisfy 0 to minus infinity. And this is equals to f of t e to the power minus st, and L, the symbol L stands for Laplace transform of. So this is called Laplace transform of function of t, or Laplace transform of f of t, where f of t is a function in time domain and fs is a function in complex frequency, and it is given as s is equal to sigma plus j omega. So this is equivalent to sigma plus j omega, where sigma is the real part, of s, and omega is the imaginary part of the s, where s is the intermediate or transformed variable, and it is a part of the exponential function. It is a part of the exponential function because it is e to the power something. So again, sigma, the sigma units Newton, and omega unit rad per second, or radian per seconds. It is obvious that Laplace transform change a function in time domain into a function in frequency domain. So in this case, convert time domain function to frequency domain conversion. This is the time domain f of t, and the frequency domain, this is convert f of s. So time domain to t to s, frequency domain, where s is equal to sigma plus j omega, and sigma unit per and frequency unit rad per seconds. Inverse Laplace transform. What is inverse Laplace transform? Just as f of s is the Laplace transform of f of t. F of t is the inverse Laplace transform of f of s. Inverse Laplace transform permits to go back from s domain to time domains, and it is given as inverse Laplace of f of s. This is the frequency domain. So inverse Laplace of f of s equals to f of t. So again changes frequency domain to time domain, and this is equals to 1 by 2 pi j minus j2 plus j f of s e to the power s of t st into ds, and sometimes this is also sigma minus j omega and sigma plus j. So sigma equals to real and omega j equals to imaginary part. Another form f of t equals to inverse Laplace of f of s equals to 1 by 2 pi j sigma minus j omega to sigma plus j omega f of s e to the power st dt. Bilateral Laplace transform. What is bilateral Laplace transform? The bilateral Laplace transform f of s is defined as follows. F of s equals to Laplace transform of function of t, or Laplace transform of f of t equals to minus infinity to plus infinity f of t e to the power minus st dt. It is satisfied minus infinity to plus infinity, because 0 to infinity, also 0 to minus infinity. That's why this type of Laplace transform is called bilateral Laplace transform. Laplace transform of e to the power at. This is the function f of t equals to e to the power at. This is also called exponential function. This is also called exponential function. So what is the Laplace transform for e to the power at, or f of t equals to e to the power at? Solution. The Laplace transform of the function e to the power at, or f of t equals to e to the power at, is represented by f of s, and it is given by this is f of s. F of s equals to what? Laplace transform of function f of t equals to e to the power Laplace transform of e to the power at, and this is equivalent to 0 to infinity f of t e to the power minus st dt. This is the formula. Just put here e to the power at in this position. F of t equals to e to the power at, and then integrate 0 to infinity. Put f of t equals to e to the power at, put f of t equals to e to the power at, then we get Laplace transform of e to the power at. Laplace transform of e to the power at. This is our target. Laplace transform of e to the power at equals to 0 to infinity e to the power minus s minus a whole into t dt. Then integrate. What is the integration? E to the power minus s minus a whole into t divided minus s minus a 0 to infinity. Just put t equals to infinity and t equals to 0. Common minus 1 by s minus a, this portion common, and then e to the power minus s minus a whole into t, put t equals to infinity and t equals to 0. And this part equals to 0, something to the power infinity. This is equals to 0, and this is equivalent to something to the power 0 equals to 1. Then we get e to the power Laplace transform of e to the power at equals to minus 1 by s minus a, 0 minus 1, and minus minus plus. So e to the power at, or Laplace transform of e to the power at equals to 1 by s minus a. This is the answer, or this is the Laplace transform 1 by s minus a, Laplace transform of e to the power at. Laplace transform of e to the power at equals to 1 by s minus a. And what is the inverse Laplace transform? As the inverse Laplace transform is denoted by the letter L inverse, and therefore the inverse Laplace transform of 1 by s minus a, this is the 1 by s minus a, is e to the power at, and expressed as inverse Laplace of 1 by s minus a equals to e to the power at. Then again frequency domain to time domain conversion. This case time domain to frequency domain for Laplace transform. This is Laplace transform, and for inverse Laplace transform frequency domain to again inverse Laplace frequency domain to time domain. This is the time domain, frequency domain to time domain conversion. Next function, e to the power minus at. Previous case, e to the power at, and in this case e to the power minus at. That means a equals to minus a. Just put a equals to minus a, because previous case 1 by s minus a. In this case just put minus a. That means 1 by s plus a. 1 by s plus a. So proved. Exponential function Laplace transform of e to the power minus at or f of t equals to e to the power minus at. What is the Laplace transform? The Laplace transform of the function e to the power at or f of t equals to e to the power at is represented by f of s, and it is given by f of s equals to Laplace transform of f of t equals to Laplace transform of e to the power at equivalent to what? Laplace transform of e to the power at equals to, already proved, 1 by s minus a, and put just a equals to minus a, and put here a equals to minus a, and we get e to the power minus at, or Laplace transform of e to the power minus at equals to 1 by s plus a, because in this case a equals to minus a, put here a equals to minus a, then we get 1 by s plus a. This is the Laplace transform for e to the power minus at. Laplace transform of e to the power minus at equals to this function. Then inverse Laplace transform. As the inverse Laplace transform is denoted by the letter L inverse, and therefore the inverse Laplace transform of 1 by s plus a is e to the power minus at, and expressed as inverse Laplace transform of 1 by s plus a equals to e to the power minus at. This is also again frequency domain to time domain. Previous case time domain to frequency domain Laplace transform, and inverse Laplace transform. This is the inverse Laplace transform. Inverse Laplace transform case frequency domain to Laplace transform. This is the Laplace transform for e to the power minus at. Next case, e to the power j omega t. So put a equals to j omega. The Laplace transform of e to the power j omega or f of t equals to e to the power j omega. In previous case, e to the power at, e to the power a of t. In this case, a equals to j omega. In this case, a equals to j omega. So put 1 by s minus a in position a. Just put here j omega. Just put here j omega and calculate the Laplace transform of f t equals to f of t equals to e to the power j omega t. The Laplace transform of the function e to the power at, previous case of f of t equals to e to the power at, is represented by f of s, and it is given by f of s equals to it. Laplace transform of f of t equals to Laplace transform of e to the power at equals to 1 by s minus a. Put just a equals to j omega. Then we get, just here put a equals to j omega. Just put here a equals to j omega. Then we get 1 by s minus j omega. And simplify numerator denominator multiplying by s plus j omega, and we get s plus j omega by s minus j omega into s plus j omega. Then multiplying right hand side a plus b into a minus b, s square plus omega square, and numerator s plus j omega, and e to the power j omega t. E to the power j omega t equals to what? Cos omega t plus j sine omega t. E to the power j omega t equals to cos omega t plus j sine omega t. This is De Morgan's theorem. Then split s by s square plus omega square, because this is the real part. This is this portion real part. So put split here s by s square plus omega square, and another part j omega by s square plus omega square. This is imaginary part. So this is left hand side and this is right hand side. Comparing left hand side and right hand side, then real part equals to real part. Laplace transform of cos omega t equals to s by s square plus omega square, and Laplace transform of omega t sin omega t equals to omega by s square plus omega square. So comparing both sides, real and imaginary part, Laplace transform of cos omega t equals to s by s square plus omega square. This is the real part. And Laplace transform of sin omega t equals to omega by s square plus omega square. This is the imaginary part. And again, inverse Laplace of s by s square plus omega square. This is the frequency domain. So inverse Laplace, and then again convert cos of omega t frequency domain to time domain. Again, for this function, omega by s square plus omega square, inverse Laplace of omega by s square plus omega square equals to sine omega t. This is also very important formula for Laplace transform. This is for cos omega t. This is for Laplace transform sine omega t. This is for cos omega t inverse Laplace. This is for sine omega t inverse Laplace transform. Then put again e to the power minus j omega t. That means a equals to minus j omega. What is the problem? Sine and cosine wave Laplace transform of e to the power minus j omega t, or f of t equals to e to the power minus j omega t. What is the solution? Just f of t, Laplace transform of f of t equals to Laplace transform of e to the power at. This is the solution 1 by s minus a. In this position, put a equals to what? A equals to just minus j omega t, minus j omega t. That means 1 by s minus j omega. This is e to the power minus j omega. A equals to minus j omega. Put a equals to minus j omega. A equals to minus j omega. Then we get a equals to j omega. Then 1 by s plus j omega. Then again numerator denominator multiplying s minus j omega, and we get left hand side. This is the divergence theorem, cos omega t minus j sin omega t, and right hand side s minus j omega by s square plus omega square. Again split. This is real part and this section imaginary part, and we get this is the s square plus s by s square plus omega square, and minus omega by j omega by s square plus omega square. So comparing both sides, real and imaginary part, and we get Laplace transform of cos omega t. This is the real part, and this is equivalent to this function s by s square plus omega square, real part. And this is the imaginary part. This is the imaginary part. J cancel, and Laplace transform of sine omega t equals to omega by s square plus omega square. Laplace transform of sine omega t equals to omega by s square plus omega square. This is imaginary part. Again inverse Laplace transform of s by s square plus omega square equals to cos of omega t, and Laplace transform of omega by s square plus omega square equals to sine omega t. So this is the inverse Laplace transform for Laplace transform cos omega t equals to s by s square plus omega square. Laplace transform of sine omega t equals to omega by s square plus omega square. And this is the frequency domain to time domain conversion. And next function, unit step function. Unit step function means just constant unit. This is the unit step function. If this is t and this is r of t input, or u of t. This is u of t. And this is the step function, constant magnitude step function. Then f of t equals to 1 or equals to u of t. What is the Laplace transform for u of t equals to 1? Just solve. The Laplace transform of the function e to the power at equals to what? E to the power at equals to 1 by s minus a. Just put a equals to 0. If a equals to 0 in this case, put a equals to 0. A equals to 0. E to the power 0 into t. E to the power 0 into t means 1. So f of t equals to 1. This is the function. So put here a equals to 0. This value equals to 0. This value equals to 0. And we get Laplace transform of 1 equals to what? Laplace transform of 1 equals to, just put here a equals to 0, 1 by s. So Laplace transform of 1 equals to 1 by s. And inverse Laplace transform of 1 by s equals to what? Inverse Laplace transform of 1 by s equals to 1. So transform of 1 by s is 1, and expresses the inverse Laplace of 1 by s equals to 1. So like unit step function, for unit step function, Laplace transform of unit step function or Laplace transform of 1 equals to 1 by s. Then again, another problem, Laplace transform of u of e to the power t, that means put a equals to 1, put a equals to 1. What is the Laplace transform for e to the power t? So again, this is the exponential function, and we get Laplace transform of e to the power t, or unit step function f of t equals to e to the power t, and the Laplace transform of the function e to the power at, this is the previous case, or f of t equals to e to the power at is represented by f of s equals to Laplace transform of f of t equals to Laplace transform of e to the power at, already proved, 1 by s minus a, and put here a equals to 1, just put here a equals to 1, and then this is a equals to 1. That means Laplace transform of t equals to 1 by s minus a. Laplace transform of t equals to 1 by s minus a. So put a equals to 1, and we get e to the power t, Laplace transform of e to the power t equals to 1 by s minus 1, because a equals to, put when a equals to 1, a equals to 1, this is the Laplace transform. And therefore Laplace transform of e to the power at equals to, in left hand side, this is the exponential function, so split and expand or span. Then Laplace transform of e to the power t equals to what? E to the power t equals to 1 plus t by factorial 1 plus t square by factorial 2 plus t cube by factorial 3 plus t 4 by factorial 4 dot plus t to the power n by factorial n. So this is the exponential function, expansion of the exponential function. And right hand side, just common s and get 1 by s into 1 minus 1 by s. Then split. This is also this function right hand side, and right hand side, this is the 1 minus 1 by s whole to the power minus 1. This is the binomial form, 1 minus 1 by s whole to the power minus 1, and this is equivalent to, this is 1 by s, and 1 minus 1 by s whole to the power minus 1, this is equivalent to 1 plus 1 by s plus 1 by s square plus 1 by s cube plus dot plus 1 by s to the power n. This is the binomial form. So this portion exponential function, and this is the binomial split function. Then comparing left hand side equals to right hand side, and we get, just compare left hand side equals to right hand side, and we get 1 by s, this is multiplying, first time multiplying 1 by s square 1 by s cube plus 1 by s to the power 4 plus dot 1 by s to the power n. And then comparing both sides, left hand side and right hand side, we get Laplace transform of 1 equals to what? Laplace transform of 1 equivalent to Laplace 1 by s, and Laplace transform of t by factorial 1 equals to 1 by s square. Similarly, Laplace transform of t square by factorial 2 equals to 1 by s cube dot. So after comparing, this is the Laplace transform of 1 by s, already proved, equals to 1 by s, first term. Second term, Laplace transform of t by factorial 1 equals to 1 by s square. And third term Laplace transform of, or Laplace transform of t equals to factorial 1 by, just multiplying factorial 1 by s square. And next term, Laplace transform of t square by factorial 2, this is parabolic function, equals to 1 by s cube, or Laplace transform of t square parabolic function equals to factorial 2 by s cube, and Laplace transform of t to the power n by factorial n equals to 1 by s to the power n. That means Laplace transform of factorial t to the power n equals to factorial n by s to the power n plus 1. This is very, very important formula for Laplace transform. Laplace transform of t to the power n equals to factorial n by s to the power n plus 1. Then inverse Laplace transform. Laplace transform of unit step function equals to 1 by s, and inverse Laplace transform of 1 by s equals to 1. This is the frequency domain to time domain conversion. And second function, Laplace transform of ramp function, Laplace transform of t equals to 1 by s square, and Laplace transform of t by factorial 1 equals to 1 by s square, or inverse Laplace transform of 1 by s square frequency domain to t by factorial 1, or Laplace transform of 1 by s square equals to factorial 1 by s square equals to t. Again, Laplace transform of t square equals to factorial 2 by s cube, or Laplace transform of t square by factorial 2 equals to 1 by s cube, or inverse Laplace transform of 1 by s cube. This is the right hand side term, and equals to t square by factorial 2. This is the frequency domain to time domain conversion, or Laplace transform of factorial 2 cross multiplication by s cube equals to t square parabolic function. Then Laplace transform of t to the power n by factorial n equals to 1 by s to the power n plus 1, or Laplace transform of t to the power equals to factorial n by s to the power n, or inverse Laplace transform of this term factorial n by s to the power n plus 1 equals to t to the power n, or inverse Laplace transform of 1 by s to the power n equals to t to the power n by factorial n. This is the inverse Laplace transform frequency domain to time domain conversion. Then Laplace transform of e to the power minus alpha plus j omega whole into t. This is also very important formula. Here a equals to what? A equals to minus alpha plus j omega. Here a equals to minus alpha plus j omega. So put here s minus a equals to this function. Put here minus alpha plus j omega. Laplace transform of e to the power minus alpha plus j omega t, and plus or f of t equals to e to the power minus alpha plus j omega whole into t. What is the solution? The Laplace transform of the function e to the power at. This is the common function our. So, or f of t equals to e to the power at is represented by f of s equals to Laplace transform of f of t equals to Laplace transform of e to the power at, already proved, 1 by s minus a. Proved here it a equals to what? A equals to this function minus alpha plus j omega. Put here a equals to this, then we get 1 by, or a equals to, put here minus alpha plus j omega, then we get, put here a equals to minus alpha plus j omega, then we get e to the minus alpha plus j omega whole into t, and this is equivalent to 1 by s minus alpha plus j omega. Just put a equals to this function, or put a equals to minus alpha plus j omega. Then this is equivalent to s plus alpha minus j omega, and split left hand side and right hand side, e to the minus alpha t into e to the power j omega t. Right hand side s plus alpha minus j omega, left hand numerator denominator multiplying by s plus alpha plus j omega, s plus alpha plus j omega. Then split again left hand side and right hand side, we get left hand side equals to, for this function, this is the De Morgan's theorem, cos omega t plus j sin omega t, and for this function a plus b into a minus b, a plus b into a minus b, a square plus b square, and numerator s plus alpha plus j omega. Then split real and imaginary part. This is the real part and this is the imaginary part. So left hand side real part, this is the real part, and right hand left hand side, this is the imaginary part. So comparing both sides, real and imaginary part, we get Laplace transform of e to the power minus alpha t cos omega t plus j sin omega t, and right hand side real part s plus alpha whole square plus omega square plus j omega by s plus alpha whole square plus omega square. Then real part equals to this first part t to the power minus alpha t cos of omega t equals to first part s plus alpha plus s divided by s plus alpha whole square plus omega square. This is the right hand side part and this is the left hand side part. Laplace transform of time domain to frequency domain. And again, second part, Laplace transform of j sin omega t equals to omega by s plus alpha whole square plus omega, so j cancel. Then Laplace transform of e to the power minus alpha t sin omega t equals to omega by s plus alpha whole square plus omega square. And this is the inverse Laplace transform for s plus inverse Laplace of s plus alpha divided by s plus alpha whole square plus omega square equals to this function e to the minus alpha t cos of omega t.